as module developers, we want our module panel to reflect the information we've calculated. We don't want to necessarily use UMI's version because that's the point of developing a module. So we're going to learn how to do that. We've learned about how to set project level settings, and we've used that to create occupant density overrides that we use for our simulation. Let's talk about the simulation panel, which we haven't really paid a lot of attention to. You've been clicking this button, but we haven't talked about this top part. And it's still showing the occupancy that was calculated by UMI using original values, not our overridden values. To reiterate, if we do our calculation, we'll see different numbers. We see 3 for retail, 6 for office, and 8 for residential. But the UMI numbers are much higher because this is still using the value that is calculated by UMI itself, which is represented in the buildings panel. Let's close Rhino and go back to our project in Visual Studio. The panel directory, the panel folder, holds most of the important code that defines the panel, but not all of it. A fair amount of it is also in this module.cs file. Module.cs is the file that defines a lot of the top level module configuration. And as it turns out, a lot of that is relevant to the panel because the module is a globally persistent sort of object that maintains information that can be used for the panel. And that's the way this works. Okay. And there are a few things I want to call out specifically inside this module.cs file. The first thing is that it's a class, right? And it is called module, and this colon UMI module means that it is an UMI module. And that's how it's able to do things like specify a tab header tooltip or specify some project settings that UMI needs to maintain for it. It also has some other things in it. One thing it has is this dictionary called selected building occupancy. And this is a dictionary that maps object IDs, Rhino object IDs, to occupancies. And this is specifically only for selected buildings. And this is how, when you select and deselect buildings inside Rhino, that selected building occupancy value can update immediately based on what people pick. Okay. Another thing I want to call out is this function here, add buildings to selection. Okay. And this function is called whenever the user selects a new Rhino object or a set of new Rhino objects. This is something that the Visual Studio template you installed just builds for you automatically, but it's worth reviewing how it works. So the first thing it does is it checks to see if a project is even loaded. If no project is loaded, if there's no UMI context, it doesn't do anything. It just aborts immediately. And then what it does is it says, given the Rhino objects that were selected, look up the corresponding UMI buildings for those Rhino objects. That's what this does, UMI context.buildings.for objects. And for each of those buildings, set its occupancy in that dictionary up here. So selected building occupancy. For that ID, we set it to the UMI building occupancy value that UMI calculated. Or if there isn't one, we just use 0. So this filter is necessary because sometimes users can select objects that are not UMI buildings, in which case we don't want to set occupancy for them. And then we need to actually load the information into the dictionary so that the user can see it. So if we want to make our module panel not use UMI's pre-calculated occupancy, but use our own occupancy, what we need is to change the code in here that keeps track of this sort of thing. Okay. So the first thing we should do is we should change add buildings to selection. And we're going to change it to actually use our better occupancies. Now, for that to work, we need to actually store our better occupancy somewhere. Now, they are stored in the database. That is a place we persisted them. And that's important because that's how you can do analysis and that sort of thing. But the database is not the right place to store information that you're using to display quickly in a UI. It's not designed to be fast enough for that. If you want a dynamic UI that responds to user clicks, you should keep the information backing it directly in memory. You shouldn't rely on the database for that. So we're going to create a second copy of this information just in memory that won't be saved when Rhino quits, but that can be used to update the panel. And that is going to be another dictionary. Okay? And we are ourselves going to map building IDs to better occupancies. And we're going to use the unrounded values, the double precision ones. And I want to be clear that this is different from the selection dictionary. This is the dictionary that holds the occupancies of all the selected buildings. this is going to hold all the better occupancies we've calculated for the entire project, whether the building is selected or not. We're not going to talk about how to populate it first. First, we're going to use it, and then I'll show you how you can actually put information in here so it's useful. Okay. We need to give it a default dictionary when we start, so we'll just do it like this. Okay. So now let's go down to add buildings to selection. We're still going to set the selected building occupancy value because the selection logic hasn't changed, right? When you select a building, you want to see its occupancy. That part's not different. What's different is that we're not going to use UMI's occupancy. We're going to use our new better occupancy. So let's do this. Okay. That dictionary was called all better occupancies. And we're going to try to get a value out of it. And that the key in this dictionary, the thing we're looking up, is going to be the UMI building ID. And we're going to store the result into our better occupancy. So if we find a better occupancy, we'll load it into this variable. If we don't, it'll be the default value of 0. And now, instead of using UMI's occupancy, we're going to use our better occupancy. Now, selected building occupancy, as we've seen, uses an integer. This is forcing the rounding because you can't have half a person in a building. So we'll just go ahead and convert this decimal version into an integer. And there are a couple of different ways to do that. This is how we're going to do it. We just tell C# force convert it, say chop off all the decimal points. This is quick and dirty, but it's what we're going to do. So now, instead of that panel doesn't use the UMI occupancies, it uses our own. Let's go ahead and make sure it's doing that. Open our project. And we look up our panel and, oh, all the values are 0. Even after we calculate, all the values are 0. And this is actually expected. The reason it is expected is that we never populated this dictionary. We had never actually stored any better occupancies in here. And that's something we're going to have to do. Okay. So let's create a method to do that. And to set a better occupancy, we need 2 things. We need a building ID, and we need a value. And once we do that, all we say is all better occupancies for that building. Is that occupancy? So we've created a method that allows us to set these values. Now we need to call it somewhere. Okay. So let's go ahead and call it from inside our command that calculates them. That's a logical place to do it. After we calculate the better occupancy, let's save it in a place that our UI can actually get access to it. Okay. So we're going to go here. After we've calculated it and printed it to the screen, after we've saved it to the database, let's go ahead and load it into the module object so that the UI can see it. And the question is, how do you get this? How do you get to set better occupancy? Well, this class is called module. Okay. Module dot, it's not here. And the reason it's not here is that we don't actually have an instance of our module to get access to. Basically, what's going on here is that this file defines a module, just in the abstract. Now, the Rhino runtime is responsible for taking this class and turning it into an object that gets loaded into Rhino and can do things. But when the Rhino runtime does that and creates a module from this definition, Rhino doesn't give you access to that object directly. So you need to give yourself access if you want it through something called a static instance. This is relatively straightforward. The details of why this works are not important for this workshop specifically. So just copy down what I'm typing here. Okay. We're going to define our static instance of this module. Okay. We're going to say it can be read and it can be written, but only by this object itself. And then after we create an object, which again, we don't do this, Rhino creates the object. All we say is, hey, give everyone access to this instance. So anybody can do it, not just Rhino. So we've created our static instance, okay, and we've set it in the module constructor. And now in our command, we can say module.instance. And now we have access to all of these methods here that we've created, such as set better occupancy. And the two things we need to do that are the building ID and the occupancy itself, which was calculated right here. Okay. And again, remember, this can be unset. That doesn't really make any sense in the UI, so we need to give it a default value. We'll just say 0. If they haven't selected any buildings that have occupancies calculated, that's basically like 0. Okay. So now, once we calculate it, it should show up in the UI. Let's give it a shot. Okay, we go to our panel. Let's calculate some better occupancies. We got 3, 6, 8. And now this should update. There it is. We got 6, we got 8, we got 3. We can multi-select to get a sum. All the same behavior we had before, but using our better occupancies now instead of the built-in UMI ones as we wanted. Okay. Now, there is one thing we're not doing. I'm going to go ahead and close Rhino and reopen it to demonstrate this. All right. Is that occupancy selection going to work? It turns out that it will not. Right. If I haven't run my command and I go to select these buildings, they're all still 0. And the reason for that is that we're only setting the better occupancy values when we calculate them. But when we open a project, even if we've calculated them before, this code isn't being run because the data is in the database, but it's not anywhere else. So what we want to do is we want to say when our module loads, let's go ahead and load it out of the database too. That is also something we do in module.cs. There are a lot of methods in here you can change. The one we care about right now is called onProjectOpened. And when this code runs every time a new UMI project opens. So what we're going to do is we're going to, when the project is opened, go into the database, pull all the better occupancies out of the database, and load them into the dictionary we're using to power the UI. And here's how we do it. We go through the new project context. So this is the context for the thing that just got loaded. We're going to get every database object in it. Okay. Dot get objects. And we're going to see for each of these objects if it has better occupancy stored. And now the thing you need to look up is the name of that data series we made. So that's the same data series name that we picked when we saved it. This here, right here. This is the key in the database for this data series, so it has to match. So we'll copy that over here. In quotes. And we'll load, if that data series exists, we'll load it up into this series variable. Okay. If it doesn't exist, we just won't do anything. So try get value will return false if there's no such data, and we just won't pay any attention to it. We'll skip all this business. Okay. But if we do find a series, then we just load it into our in-memory dictionary. Now, if you remember from before, we had to translate a Rhino object ID into the format that the database stores it in. When we read data out, we need to reverse that process. So we did it one way by calling toString. We reverse it by calling this method called good.parse. And we parse the database object ID, and that's the key. And then we just set it to the into the data that we received out of the database. So remember, this was a data series that only has one value in it. So we say, okay, get the first value out of that data series, and then truncate it, convert it to an integer, because that's how all of our all of our occupancies will be displayed in integer form. And this code will run every time we load a new project. So hopefully it will load the data that we've previously saved in the database. Let's see if it works. So I should be able to see the updated occupancy values in the panel without having to recalculate anything. And there they are. So we've discussed how to update the UI from the created example module to actually use our new simulation result, and how to load that simulation result from the database when a project is opened.